Okay, so yeah, we're gonna go over the homework today in the beginning of class, and if you spent a ton of time on it and you're now thinking, really, we're just gonna go over the homework now, all of that time you already spent on it, trust me, it's gonna help you out in the end. Even if you didn't get like anywhere, I guarantee you still learned some stuff. And also, I really want you guys to take a look. Let me put that like this. I want you to take a look at the supplemental exercises that I gave you too. So I have two of them. So one of them is called pictures, and you don't have to do these, right? And this is just for your benefit. So you have a spreadsheet again, and then you can work on making all of these figures. And the other one called Angel's Home Runs. Got the data sheet. I think you already have this actually. But anyways, then you can make this graph here. All right, so this is similar again to the homework. It's similar to the project for a lot of the techniques. I'm not going to say all of them, but it's a lot of them. All right, so question, if we hard-coded on the homework, we still get full credit, right? Because it's completion. Yeah, so yeah, if you did hard-coding on the homework, you know, it's not great, but that doesn't matter. The homework is on completion. And especially for this homework too, I know this was hard, so I'll grade this one a little easier too. But we're going to go over the majority of the homework right now in class. You still need to turn in the homework though today. But anyways, for these supplemental exercises, again, I'd recommend you to do them by yourself. Like really give them a good effort and see if you can get them. And if you can't, I'll upload these solutions also. Maybe not today, but a little later this week. All right, so any questions before we go over the homework?
And for the supplemental assignments, the stuff is that what we covered with those videos you posted, right?
Yeah, it's not the same graphs I have in the videos. I don't think so, but it's a lot of the similar techniques. Yeah.
Okay, thank you.
Yeah, I'm pretty sure it's not the stuff I have in the video. I have to check though. All right. Also, actually, I want to ask, how's the project going? I asked in Discord. I only got like a few answers, so you still have a while to work on it. But how's the project going so far?
No, I forgot. When is it due again? Sorry, I have.
I don't even know. I forget.
I
I
worked
think
on
it's
some other Matlab thing that I thought was pretty cool, but I mean, this is a different topic, so.
yeah. It's I think it's due in like 3 weeks from now.
All right, then I could start working on it this week once I get the homework done. Because I think
Yeah.
once I finish this homework and watch this class, then I could understand the project better.
Mm-hmm. Yeah, I think I actually still need to make an actual assignment page on Canvas, but it's on here. It's due on the 26th. Alright, I'm just looking at the comments now. Yeah, DJ, yeah, you're already pretty far in the project. Okay. So at least most of you hopefully got started on it, at least to some degree, and this homework should help out too, and same thing with the supplemental stuff. Alright, so let's go over the homework first. And then we're going to go over brand new stuff. So I have the new slides on Canvas. It's for programming. So we're going to get started on that today. And we're probably just going to go over logical operators, which we've actually been using a few times. But we'll go over that in more depth. And on Wednesday, we'll probably start if and else statements. And then after that, we'll hopefully start looping. Right, so homework, I'm going to do it in here again just because it's easier for some of the stuff we have to type out. But it's still Matlab. So first thing, I just have importing the data. You guys know how to do that. This is something I've just started doing at least more recently. So I'm in my script right now. And everything in here, these are all scripts. And I have my 3 folders for code, another folder for data, and then a folder for figures. So I have all my data in this data folder, and basically I'm telling MATLAB to get that data in that folder. So these two dots means to go back one folder, and then I tell MATLAB to go into my data folder. Right. So next thing, converting. So sometimes this is more apparent for when you need to convert something. Like you might not know what you need to convert from the get-go, but if you try to do something later on, it might say that you can't use this operation with a cell. So usually that's when we use logical operators like our equality operator with the 2 equal signs, stuff like that. So we need that to be a string, not a cell. So we'll actually just do one of those conversions right now. I'm going to first run the script. And let's open this up here. Okay, so we have our workspace. Let me make this smaller too. Okay. And let's make this smaller too. Alright. So if I go to my workspace or my command window, which is this box here, and you can do this on your computer too, we'll type in class of t.events, and that'll give us the class type we have for that column. It says it's a cell, so events is column 9 here. And for our homework, we need to look at when we have a single, a double, a triple, and a home run for every single year for Mike Trout. We want to get that kind of breakdown. And that looks like that's one of them. Where's the other? Oh, here. Okay, so we want to make this graph here. That's one of the graphs we want to make. So I'm not going to go over how to actually make the plotting part. You guys can still do that on your own, but I'll go up to that part. And then this is the other one that we want to make. And the colors don't matter. Someone asked about the colors. To do this color scheme, it was a little bit different. I'll show that in another video. Okay, so we want to convert this from a cell to a string, like I said. And again, that's to use logical operators with this column. So we do t.events. That's the column we want to look at. And we're going to convert it to a string by using the string function. And then do t.events. Let's run it. And now if I check the class again, now it's a string. You can see that we have these double quotes now, or with the apostrophes. Alright, so one of the things, and we're actually going to talk about this today, so and maybe we should have talked about it before, but when we're doing a script like this, we want to think about, in the beginning, what's the, I guess, the top level kind of idea that we want to achieve. So what's the most general idea that we want to achieve with this script? So in this case, that's getting this plot here and the other one. And, we can see that when we're looking at this, that we need to find the singles, the doubles, triples, and home runs, well, the amount for all of those for Mike Trout and for each year. So that's what we have to do in general. And then to kind of break it down, we need to tell ourselves, okay, I need to find basically all of the indices in this table here for each respective year. So if we look at this column called game date, it's each day and for every single game that Mike Trout has played. So we have April 2nd, and then we have April 1st, and then we have stuff from 2020. So there's a lot of stuff in here. And we need to break this down year by year, because that's what we want to do. So we need to get all of those indices for each respective year. So we need to think about how we can do that, because currently it does it day by day. All right, so separate game date column to date vec. So date vec, I don't think we ever talked about it in class. It was on one of the videos that I made though. And this date vec function will convert this datetime vector. That's also a different class. So if I do class of t.gameDate, see it's called date time. So date time, that can store the year, the month, the day, and then also the hour, the minute, and the seconds. Okay, so we want to convert this to basically just look at only the year, because we want to make our plot go year by year. So let's call this year, and we'll use our dateVec function, and then do t.game date. So that's going to make a new, basically a new matrix now for this column, where it's going to break it up into a dateVec kind of, I don't know, structure. So if I run this now and I open that, this is what we have. So in our first column, we have the year, second column, the month, third, the day, and then it goes hour, minute, seconds. We don't have that data, so it's just a 0. All right, so now we have a method to get all of the indices for each respective year. Now this is 2021, we have 2020 here, and if we keep scrolling, 2019, keep going, and basically all of the years. Okay, so now we can also use the unique function to find all of the unique years that Mike Trout has played. So we're going to do this so we can avoid hard coding. Some of you, when you asked for help, I noticed in your scripts you did some hard coding where you did like 2011, 2012, and so on. Which again, for the homework, it's okay, but we always want to try to avoid that. So, at least when we can. So get unique years. So we're going to call this, maybe I'll call this something a little different than this, like it looks a little too similar, so I'll call it unique year. Okay, use the unique function and then type in. So in this case, right, we already have in our matrix here for our dateVec matrix, we have in the first column all of the years, right? So basically, to find all of the unique years that Mike Trout has played, we're just going to run the unique function on this column in this variable called year. So to do that, we're going to type in unique, and this is going to be here. That's this matrix we're looking at here. And I want to look at all of the rows in that first column. So we're going to do colon, comma, 1. So remember, this colon means get all of the rows, or get everything of something. In this case, it's our first argument. So that means get all of the rows, and then look at the first column. And if I open unique year, we have all of the unique years that he's played. All right, so at this point, any questions so far?
So the year, when you did the unique year, the colon and 1, it was just getting the figures from that row.
Yeah, it's getting, it's looking at this entire row, right? Or this entire column right here.
Column. Oh, okay.
Yeah. So the colon means get all of the rows, and then the 1 means look at this first column.
Oh, okay. Thank you.
Oh, would that work for like any other, like for other, I would say like tables, not just with dates?
Yeah. Yep. Yeah. If it was like a string or something too, like a string array, we could do the same thing. So if this was like, I don't know, angel players or something, I could use array addressing again to just look at that entire row or a certain range, anything like that. All right, Nathan, you're having a problem getting Matlab to open the file. So for the read table part, so for you guys, I've often told you, and just because it's simpler, to put your data, put your spreadsheet file in the same folder as your script. So you could do that, and then all you would have to do is just type this in. But for me, I have my data in a different folder, so that's why I have this part. Okay, so now we want to find the indices for each year. All right, so when I say that, I want to find basically all of the rows when the year is 2021, when it's 2020, and so on. All All right, so to do this, we'll call this years IND for indices. And we're gonna need to make this a cell array because different years, they're gonna show up a different amount of times for this table. So 2021, you know, there's only been a few games so far. 2020, there's, and you know, this isn't up to date, by the way. 2020, that was a short season. 2019 was, 2019 was longer. And anyways, there's going to be a different amount of indices for each year. So remember, for a matrix or for a table, the amount of rows in each column has to be the same. So if we use a cell array, they can be different lengths because each cell will correspond to a unique table or some unique matrix. All right, so we're going to do it for the first year, which will correspond to 2011, but that doesn't even really matter. You don't need to know that right now. All you need to know is that it corresponds for, we're going to find it for the first year and a variable called year. Or, sorry, the first year and unique year. All right, so let's go here. And we're going to say, we could use our find function here if we want, or we could use just the logical operation that we kind of talked about in one of the videos, but I'll use find for now. So we can say find when year of 1 is equal to, years, actually this should be unique year of 1. Okay, I should spell year correctly. All right, so this is going to say find when we have a row in our first column of year. So basically find when, let's think of a better way to say this. We want to find basically all of the rows in this first column. So we're looking at this first column in our variable called year. Okay, so we're looking at this entire first column and we're telling Matlab to give us the rows when a value in here is equal to the first value in unique year, which in this case is 2011. So it's going to give us all of those rows. All right, so if I run this and open years IND, you see it's a cell array. And our first one, we only have one cell so far. That's a 534 by 1 numeric array. Let's open that up. So the first index, or the first row, when we have the year 2011, is in row 23,003. So let's just confirm that this is correct. So we'll go to our table T. That's going to be way at the bottom. 23,003, was that it? Yeah. Oh, I'm going too far. 23,000. Okay, 23,003. Here we go. That's the year 2011. And right above that, that was 2012. So, and then we're going to, basically, I think it'll be towards the end of this spreadsheet. So we have all of those rows or indices for the year of 2011. All right. So does this part make sense to everyone? All right, now we need to do this for the other years as well. No, not that. Length of unique year, 11. Okay. So we need to do this for all the other years. So we have 10 more lines that we need to have here. So let's do this now, and I'm gonna get this for every year. I put 01 just for formatting because later we're gonna have 10, so 2 digits there, and then 11. It's the same thing as just 1 though. Yeah, see, I just did it for this reason, so it's just nice and even, basically. All right, so we have 11 years, and so there's maybe something that might be, at least at first glance, a little tricky here. We're not going to change anything right here. This is going to stay as year, colon, comma, 1. because I want to continue to look at this first column for this date vec matrix here. I want to look at this first column because that contains every single year, basically. It has all of the respective rows for table T, but it's just broken up by year. So what we do want to change though is this over here. I kind of just do that. Okay, let's change this to like this. Okay, so we're gonna make 11 cells here. That's what you see here. Okay. So we have 11 cells here for the 11 years that we're going to be making. And we want to look at this first column in this matrix for our date vec matrix. We'll look at this first column. And then over here, it's going to change because now I want to look, I basically want to find all of the indices for our second unique year, then for the third one, fourth one, and so on. What do you mean with like how I kind of numbered this from 0 to 11 or from 1 to 11? Yeah, so that's unique to the text editor that I'm using. That's why I like using it for stuff like this. It goes by a lot faster. So yeah, in Matlab itself, I don't think you can do that. It's kind of unique to this. All right, so if I run this, let's check it out. So we have our first year, second year, third year, and so on. We have 11 years, and you see that they're different lengths, so that's why we're using a cell array. Let's check number 2 here to make sure that's correct, and then we're going to move on. All right, so this second cell is going to correspond to the second value in unique year, so that's 2012. And let's make sure that this is correct. So the first time it shows up is in row 20,398. 20,398. All right, here's 2012 or 20,398. Did I say that? Oh, 395. I wasn't up all the way. So here, okay, looks good. That's our first value for 2012. Right above it is 2013. So it's going to start here and go down to whatever number. We could check, but looks like it's working. And so any questions on this part? All right, so now we're going to do this for hits per year, or hits by year, whatever you want to call it. First one, we're going to do it, so this is just how I did it. You could do it by hit type. You could do it, basically like one section for singles, doubles, triples, and home runs, and then break that down per year. But what I did here is I'm doing it year by year, and then I'll find the singles, doubles, triples, and home runs. All right, so first one is 2011. So I'm going to make a big matrix basically here. So I'm going to call this hits of 1, 1. And so this will be a matrix that's going to contain singles, doubles, triples, and home runs. And that can be like kind of one column. And then adding on all these new columns, that's going to be for kind of year by year. So this will make more sense once we get going here. All right, so let's do, I'll first do t.events. So we're going to look at this column 9, and we want to find when a value in here is equal to single. So we're looking at t.events, and we have to use array addressing now. So we're using, this is going to be for the year 2011. So I need to use array addressing for all of those indices that we just found for the year of 2011. So let's do t.events, and then type in years, int, 1. Again, I can just type in 1, that would be the same. And this is going to get all of the indices for our first year. So it's getting all of these, and it's using array addressing on this column of t.events. So it's going to look at all of the rows for when we are in the year 2011. And in this column, we want to check for those respective rows when this is equal to single. All right, so I'm going to use that logical operator. It might be technically a relational operator, I forget, but it's basically the same thing. So we're going to check when that is equal to single. So if I run this now, okay, yeah, we are going to get an error because of this kind of size issue. I'm telling Matlab that we have a scalar that we're going to create here because it's 1, 1. But really we have a vector, so that's why it's giving us this error. Let's do a colon. This way I'm going to create a vector for now. So if I run this and I open up hits, so this is, we ran a logical operator here, so our length here is 534, which will be the same length as our indices here, because it's giving us a logical result for, it's basically looking at each row when we're in the year 2011, and it's giving us a logical result if it's true or false if we had a single. So, remember, a 1 is true, 0 is false. Okay, but we want to find the amount of singles. So that's going to be a scalar in the end. So I'll change this back to hits 1, 1, and then I'll type in sum. And I type in sum here instead of length because what we're doing is adding up all of the instances when we had a logical result of 1. So, we're doing 1 plus 1 plus 1, and so on. If I run this now, let's open that back up. Then we have an answer of 16. So Mike Trout in 2011, he had 16 singles. All right, any question on that part there? That's basically what we're going to be doing for the rest here. So this part's important to know if you understand it or not. Okay, yeah, sure. All right, so I want to find the amount of hits. Let me rephrase it again. I want to find, in this line specifically, I want to find the amount of singles in the year of 2011 that Mike Trout hit. All right, so to do that, I'm going to delete all this for now. So let's do hits of colon, 1. Let's first use a logical operator to see when it was true or false if Mike Trout got a hit. So let's do t.events. Okay, so if I want to look at when Mike Trout had a single, I got to look at this column here called the events. So I'm going to look at this, and we want to look at all of the values or all of the rows for 2011. So we already found the indices for that. That's our first cell here. Okay, so this is all of the indices for 2011. So we're going to use array addressing with those indices to look at all of the rows in this table T for 2011, and specifically in this column. Okay, so we're going to do years IND 1. And now we want to check when, for those rows, we're going to use a logical operator to check if this was if it was equal to single. I combined equal and single. Okay, so we're going to check if the value here was equal to single. So we'll type in single, and let's run this for now. Hits. So our first result that we have is a logical 1, so that means true. So let's actually show you. Let's go to row 23,003 in our table. 23,003. All right, here we are. So we can already see right now that's single, so that's good. Let's make sure it's the correct year though, too. And we'll go over here, 2011. All right, and then the next value that we had here for hits was 0, so that means false. So my chart did not hit a single again until the 10th value. So that corresponds to the 10th row. So that was 23,012 in our table. 23,012. We're still in 2011, of course. And that's also a single. So this is the first one, and then here's the second time that it occurred that it was a single. So that's why we have a 1 for those respective rows. Right. And then what we're doing is we're adding up when we have a value of a logical 1, which means true. And that way we can get the amount of times that he hit a single. So I'm going to type in sum. And now if we run this, we're going to get an answer of 16. All right. Does that make sense now to everyone? Okay. All right, so now I'm going to do the rest of this kind of a little faster, just because it's going to be basically the same as what we just did here. So now we want to do this for doubles, triples, and home runs. So I'll just go over here, and we'll take this out. So at this part, I am hard coding. I could have done something to not hard code this part, but for the sake of time now, I'm just gonna type it in. Okay, so now I want this to change to be 2. I want to put this in the, actually no, I want that to be 1. Let's do 1 to 4 there. Okay, so basically I'm going to have a 1 by 4, or sorry, a 4 by 1 vector, and that'll be for the year of 2011. And our first row is going to be for the amount of singles, second amount of doubles, third amount of triples, and fourth amount of home runs. All right, let's run this, and then we'll check out hits. There we go. He had 16 singles, 6 doubles, no triples, 5 home runs. All right, now we want to do this for our other years. I'll probably just do a few of them, but you'll see what we have to do. So this is another reason why I use my text editor. So we'll do it for 2012, 2013, we'll go to 2015, 2014, 2015. I'll just delete that part. All right, so now we want to do it for those years. Now all I have to do is change this part here. This is going to be, instead of a 1, it'll be a 2 for 2012. And then we'll change this to a 3. That'll be for 2013. Here, we're going to change this to a 4. It's 2014. And then this will be a 5 for 2015. And then the only other things that we need to change is the column that we're making this. So I want to have 2012 show up in this second column, 13 in this column, 14 in this column. You get it. All right, so that's all we have to change. So we'll do 2, 3, and then 4, and then 5. Okay, there we go. Now if I run this, there we go. Like, hardly any work, right? We just need to change a few numbers and that's it. So now we have the kind of hit profile for each year for Mike Trout. So this is for 2011, 2012, 13, 14, and so on. And you can see here that, you know, your code should look like this, and it should look like this kind of structure on your project too for some of the stuff that we're doing. You should be able to kind of set it up in this manner where it's very kind of systematic for the things that you're calculating. And, you know, what I kind of want you to think about is, wow, it seems like we should be able to do this a lot more simple, where I don't need to copy and paste this so many times and just change like one little thing in each line. You know, all we did is changed a number here and a number here. That's it, right? And that would be a good point if you think about that, because we can do this a lot more simple. We can make it more simple by using a for loop. and it would save us so many lines. But we haven't learned that yet, so we can't do that quite yet. Alright, so that's all I'm going to go over for the homework. So at this point, all you have to do is make your plots. So we had a few subplots, and then we had a bar chart that was stacked. And so to do a stacked bar chart, you just do bar, whatever your data is. You need to make sure that it's formatted right. Okay, let's just do bar of hits, and then we'll add on stacked. Okay, and this is what it looks like so far. But you need to make sure that it's formatted correctly, because look, right now we only have 4 ticks here. It's doing it by singles, doubles, triples, and home runs. We want it to be year by year, right? So basically you just need to transpose hits. Let's transpose that. And now it's year by year, and then for singles, doubles, triples, and a home run. So you would just need to pull the years here for the X-stick labels, which you can do. You don't need to type it out. And then also get your legend and whatever other stuff you have to do. Okay. Alright, so that's all I'm going to cover for the homework part, unless there's any more questions, and then we're going to start on our new chapter.
Can you quickly go over why you did 1, 2, 3, 4 instead of a colon?
Yeah, so I could have a colon if I wanted. So before I put a colon, because I actually wanted to, we were looking at the logical result if it was true or false. So if I put a colon, that gave us, and if I didn't have sum here, that gave us a length of 500 something. So I could still have a colon here if I wanted. It's going to say, give me, colon just means give me all of the values for this dimension. So here we're finding the sum. So I already know that I'm just going to have one value because I'm calculating the sum. So it doesn't really make sense to put a colon here because I know I'm going to have just one value for my answer. I'm not going to have, 500 something rows. Does that make sense?
Yeah,
I can show it a bit. Okay, I can show it a bit better too. So if I take out sum here, and then I put a colon, we have a length of 534. So the colon just means give me however many rows that we need to make this calculation. And if I put a 1 here right now, that's not going to work because we're saying that we have a scalar when really we should have a vector. And then when we add on sum, if I have a colon, it will work because it's saying get however many rows you need to do this. In this case, that's only 1 row. And we know that it should be a scalar, so that's why I just put a 1. Same thing. All right. Yeah, so will I post the video? Yeah, I always post them as soon as I can, unless I forget that day, but it takes a long time to process the video. Usually I post it when it's at least 1080p, and it's still processing up to 2K, but yeah, I'll do it as soon as I can.
Well, Patrick, I have a question. If we didn't want to hard code like singles, double, triples, we would do like the same thing for like what we do for the years, but we would do it for instead of game date, we would do it for events.
Yeah, yeah, you would do like unique of t.events, and then you would actually need to you need to find the rows when that shows up.
Okay, and then we would have to eliminate like strikeouts and stuff like that.
You could do that, or you could basically find the row when single, double, triple, and home run shows up for that unique function.
Okay, thank you.
Okay. Why? Huh. Strange. My keyboard isn't working in this window now. That's something else I've never had happened. That's okay though. I'll just hide that for now. Alright, so let's go over some of our new stuff today. Took a little longer, but I want you guys to get that stuff. So let's open up Matlab. Alright, so again, the slides, they're posted. Posted them last night. Alright, let me close out of this. And let me open up my slides. Alright, so I only have a few slides so far, but in the end it's going to be way longer than 19 slides. Alright, so we're going to be going over programming. So this is, I mean, every chapter we've covered so far is important, but I would argue that the most important chapters for our class or topics are arrays, which we've already gone over. And then after going over arrays, would be going over programming. Oh, I just realized I closed my webcam. I didn't mean to do that. Okay. I'm way too big. Alright, let me put that back down there, and let's open this up again. So we're going over programming. So again, this is probably, alongside with the arrays chapter, I would argue it's the most important chapter because it's going to save you a lot of time for a lot of operations that you want to do. Specifically, of the bunch here, I think for loops, this is the most important topic that we're going to cover. But we're going to start out by going over relational operators and logical operators, and we've actually been using them for a while now, but we'll discuss them in a bit more depth. And then, I don't know why I said logical operators twice here. And then we're going to go over conditional statements, probably, maybe this week, probably this week, if not next week for sure. Then we're going to go over maybe while loops first, actually. And we're just going to touch on them. They are important, but for us, I've actually hardly ever used a while loop on my own for whatever I'm doing. Usually I'm using a for loop because typically we already know the length of the data that we have. So if you have a spreadsheet or something that you collected for some test you ran or some experiment, you've collected all that data, you know how much data you have. So in that case, you would use a for loop. But of course, we'll discuss this in depth. Alright, so that's the plan. So we have some kind of more, I don't know, theoretical top level stuff before we get started. So why is programming useful? So it's going to simplify, and even more specifically, I want to talk about for loops. So it's going to simplify the tediousness of complex and or large problems. So for us, main focus on for loops, what we just did right now, on the homework, I had to copy and paste, a lot of lines and change just a few numbers on each line. And that was kind of tedious, even with my text editor where I could do it kind of fast. Instead, I could have used a for loop, and that would just take a few lines of code, and I could do all of that. So it'd be much faster to use a for loop. And also for complex problems, it's going to help out too. But mostly we're going to focus on just reducing the amount of time to do stuff. The amount of time for us to do it. It might be the same amount or just about for Matlab to actually run the calculation, but for us to type it out, it's going to be a lot faster this way. So one example is for finding the indices for each player. We could have used a for loop for that, and it would have gone by a lot faster. Okay, algorithms and control structures. I made these slides based off of the book, if any of you use that, at least in the beginning here, so some of this is like very specific stuff. If you want to, learn it, you can, but I'm never going to be like, all right, let's make an algorithm now. Anyways, an algorithm, it's an ordered sequence of predefined instructions to perform some task. So there's 3 types. We have sequential, so basically that's saying, all right, let's do something like 3 times 5, And now let's do A divided by 5. So we're going in order there, kind of line by line. We have conditionals, so for some question, we're going to basically see if it's true or false, and depending on that answer, we're going to do something. So that's our if statement, and else statement, and else if statement, which we'll learn. That's also very useful too. So you could think of something like if we have a spreadsheet that has temperature, if the daily high for that day was greater than 100 degrees Fahrenheit, put it into some new array that's called hot AF. So, and basically if it's not greater than 100 degrees, we could tell Matlab to do something else. Okay, and then we have iterative, so looping. We're gonna repeat some execution of code for some amount of times for some instructions that we have. So again, I'm going back to the example of finding all of the indices for some MLB players. Right, so top-down design, I kind of went over this in the very beginning of class, but we'll talk about it again here. And this will help with the homework, because I feel like for the homework and for the project, you know, you guys might, you know what you want to achieve, but it's kind of hard to get started, like to think about, okay, you know, what do I have to do to really get started? Just because it's a lot of stuff that you have to do, you know, to actually achieve that end result. So basically, I would recommend doing this right here. So I think it's beneficial to start from a very basic goal, like what is the most fundamental goal that you want to achieve with your code. So think about that first, like we talked about for the homework. We wanted to find the amount of singles, doubles, triples, and home runs per year for Mike Trout. So that's the big idea. And then we had to find, then we kind of break it down into smaller sections. So that'd be like, okay, I know I need to find all of the indices. So how am I going to do that? So you do that first. Okay, you got that part. Now what do I have to do? Now I need to find with those indices when it was equal to a single, a double, triple, or home run. So then we do that part. And then we can find the length for that as well, like how many times did this happen. And then the last part, damn microphone clipping, blame Zoom. The last part is then plotting. And you guys know how to plot now, so that part should be easy. But I would really recommend kind of breaking it down like that to take it from like some really complex, scary thing into something that's a lot easier for you to tackle. And then you can also use structured charts and flow charts. I mean, some people like them. I never use them because I think it's, at least for me, it's easier to think about my code breaking it down like I just talked about. Flowcharts, I don't know, they almost seem like too like bureaucratic or something. I'm never gonna make a flowchart unless I am told to. Alright, so this is an example for the homework again. And this is actually using looping here. So remember all of that code that we just wrote, right? It's kind of a lot. Let's actually open it up. I'm going to open up the script that I have for the full code. Not projects, homework. All right, so one of them here. Let's get, I want to go from right here. So look at all this code that I have. It goes to line 101 and we started on line, oh, I didn't mean to do that. So we started on line 22. That was a lot of code, right? And we could have used a for loop instead to do all of the same things, or to calculate all of the same things, and we could have just done it using this for loop here. So it might look a little weird right now because we haven't learned it yet, but we're using a nested for loop that we'll talk about eventually. But you can see here that I basically thought about what do we have to do. We need to find the singles, doubles, triples, and home runs per year. I need to find the indices. It's kind of broken down like that. So that's this part right here. And then I need to find the amount of each hit type per year. So that's just this part right there. All right. And if any of you want to kind of run this and take a look at it on your own, you can do that and you can kind of get a little taste of for looping. Alright, so general programming tips. You want to use concise, relevant variable names. And really for your project, it's going to help me too a lot to grade your project when I look at your code. Like last semester, I'm not going to single anyone out, but last semester I had a few students that used like random variable names. So if it's a random variable name, it's a lot harder for me to know what you're trying to solve for. So for our homework, if we were finding the home runs, right, I like just in one variable, I could call that home run angels. And I'm not going to call it like Batty McBatface because that's not giving me any indication that I'm solving for the home runs. So don't do Batty McBatface. Right, breaking up code by sections and comments throughout your code. We've talked about that multiple times, but you really want to make sure that you want to do that. It's going to help you yourself, and it's also going to help me a lot too to read through your code and see what you're trying to do. Alright, so now we're getting into some stuff here. So relational operators and logical variables. So we've gone over some of these already, but we haven't gone over all of them. At least I don't think so. So these are all of our relational operators. So we have less than or equal to, greater than, or equal to, which is what we use quite often. And we also have not equal to. So in some programming languages, actually probably a lot, instead of a tilde here, you have an exclamation mark and then an equal sign to be not equal to, but in Matlab, you have a tilde out in front. And then, yeah, you want to make sure that you remember that this equality operator, that's a logical operator. That's two equal signs. One equal sign, that's the assignment operator. So we're saying, like, I want to make some variable called, I don't know, A. A is assigned to some values. That's when we have one equal sign. All right, here we go. So now we're starting. So again, we've already gone over a lot of this before, so we'll go over the stuff we've gone over before a little bit faster. But once we start going over conditional statements, we'll take our time on that. So relational operators, they're going to have a logical output. 0 is false, 1 is true. We know that. So if we run this here, if we have x equal to 40, y equal to 20, TOF for true or false, equals to x less than y. So this line here is going to check, it's going to run a logical kind of operation to give us the answer for x less than y. So is 40 less than 20? We know that's not true, so we're going to get a logical result of 0, which means false. Alright, so let's look at this one. We have x equals 4, y equals 7, z equals 4, and true or false once again. So we're going to make a variable called k, and we're going to get a logical result for if it's either true or false for x being equal to z. So is 4 equal to 4? Yeah. So that's going to be 1. That'll be true. Next one, I guess I have all of the answers right away. Next one is x plus z less than y. So we have x plus z, that's 8. Yep, I didn't know if I was looking at the right one. So yeah, we have 4 plus 4, we have 8. I guess I wrote that down wrong. Oops. So we have 8 is 8 less than 7. That's what that should have said. I gotta fix that. So 8 is not less than 7, so we have a result of false, and that's gonna be a 0. Alright, so sure, what do you guys think the output is gonna be for this? So we have x plus z, so we have 4 plus 4, and then less than y plus 5. So we're going to get a logical result here. And what do you think it's going to be? A 1 or a 0?
One.
Alright. Yep. it's a 1, it's not a 0, and this is true, right? We have x plus z, that's 4 plus 4, that's 8. So we have 8 on the left-hand side here, and then on the right-hand side of our relational operator, we have y plus 5. So we have 7 plus 7, 14 plus 5, 19. Is 8 less than 19? That's true, so we get a logical answer of a 1. Maybe that was a bit of a trick question because we talk about precedence next. So how about for this? I mean, I already have the answer up. So we have x plus z. So, oh yeah, so I actually wrote this a bit different. This is actually a good point here. So I wrote this a bit different because this is doing our logical operators first. So we're getting our answer for the logical operator. So it's doing those first, and then it actually ran a mathematical operation on this. So we have x plus z less than y plus y. So that was true. So that gave us a 1, and then we added on. Now it's plus 5. So now we're doing a mathematical operation to do 1 plus 5, which is going to be 6. So if you're trying to do a logical operation like this, or like this up here, you want to be careful with how you type stuff out, because it might change if you get a logical result or not. So yeah, you want to be careful with how you type this stuff out, because really we ran this logical operation here in parentheses, so that was done first. That gave us an answer of 1. But then all Matlab sees is now do 1 plus 5, and then that gives us 6. Okay, so relational operators, they have equal precedence, so they're going from left to right. So if I go back here, all of these have equal precedence. Alright, so we'll actually just go through here. So for K1, we have 3 less than 7 not equal to 2. So we have 3 less than 7. Is that true? Yes, that's true. So then we're going to have 1 not equal to 2. Is that true? That's true. 1 is not equal to 2. So again, you need to like watch out for what's actually occurring in this operation here. Alright, so we have 3 less than 7. This will actually be the same kind of thing here. That's going to be true. Then is 1 less than or not equal to 2. That's true. And here we have 3 less than. Now, because this is in parentheses, this is going to be done first. So is 7 not equal to 2? That's true. And then Matlab is going to check, is 3 less than 1? 3 is not less than 1, so we have a logical result of 0. Alright, so we can compare arrays, which is, we're starting to do stuff that's a little more familiar to what we've been doing so far in the class. We've been doing stuff that I think is a lot more relevant, really, because, you might do stuff like this sometimes, but, the stuff that I did before is a good way to learn what logical operators are doing, but in practice, what we've been doing on like the homework and stuff, I think that's more relevant to kind of real life stuff that we would do. So here, it's going to go element by element for how this works. So it's going to check each respective index for these 2 vectors that we have here, and it's going to basically check if they're the same. Okay, so we have A and B. Sorry, not if they're the same. I shouldn't have said that. That would be if I use the equality operator, but here we're not doing that. We're creating some vector called high, so I totally, do as I say, not as I do. I shouldn't have called this high, because that doesn't make sense. But anyways, we're checking if A is greater than B, and it's doing that element by element. So is 3 greater than 3? No, so we get an answer of 0. Is 4 greater than -2? Yeah, so we get an answer of 1. Is 7 greater than pi? Yeah, we get an answer of 1. Is 10 greater than 20? No, get an answer of 0. So the lengths, they have to be the same. Okay, so we can do array addressing with relational operators too. So here I'm first, let's block that out, right? Forget that x is out there in front. we're first checking is each value for x less than the respective value in y. So we're seeing when that is basically true. So is 900 less than 300? No. So that's an answer of 0. Is 90 less than 90? No. 44 less than 20? No. 21 less than 22? Yes, that's true. And remember, in our homework, we actually used array addressing like this. So basically, when we get an answer of true, we can use that 1 as kind of a way to use array addressing. So in this case here, when we have an x out in front, this is going to then look at our 4th row. So we have x less than y. It was true for this value here. So it was true for this value of 21. So now if I use array addressing for looking at this vector x, that was true for the 4th value. So then we're going to spit out that value of 21 right here. All right, so that's just like what we've been doing in the homework. I think we did it for the homework that I just showed you. Let me check, just because we have time. Yeah, you know, we actually calculated the sum, so I guess we didn't do array addressing here, but in one of the videos I know for sure I did that, but basically I could do like t.events, and then if I ran this, basically we would just get a single, because it's just telling us we're using array addressing for that. But in one of the videos I made over the weekend, it shows you that. All right. Okay, so we're using the find function. Some of these slides were made, well, the vast majority of these slides were made from last semester. I kind of edited some of them. So we can use the find function. And basically, you know, that's doing our relational operator. And then it's going to find the index, at least by default, when that logical... Jeez, I need to stop talking too loud. When the logical result was true. Okay, and that way it can find that respective index. So here we're finding when b is less than a. So 2, that's less than 20. Let me actually run this over here. Okay, so 2 is less than 20. 40 is not less than 21. 70 is not less than 22. 5 is less than 23. So if we run our logical operation here, which is b less than a, it's going to give us a value of 1 here, then 0, 0, and then 1. And if we combine this with our find function, find is going to give us the indices when that logical operator was true. It's kind of like using array addressing right here in a way, because it's giving us the rows when the indices when this was true. And that's 1 and 4. So you guys should be familiar with this part here. All right. Okay, let's go on. We're actually going to end maybe a bit early. I wasn't thinking we would get this far. So Matlab has 5 logical operators. You might hear them called Boolean operators too. And as with the relational operators that we just went over, they go element by element. So the precedence is different here. We have lower precedence than arithmetic and relational operators. So arithmetic and relational operators, they're going to be operated on first, and then these logical operators will be operated on. So besides the not operator, I think the not operator, that has higher precedence than these two here. All right, so we used some of these two. Basically, probably just and. Probably only used this one before. But the not operator is a tilde. Actually, we used this one time in class. So the not operator is a tilde. So you can read through what it specifically does, and we will have a few examples. Okay, so this is going to return an array of the same size or same dimension, and this array is going to have ones where A had zeros. So if I was like back here, it would, if we did not here, this would basically return 2 and 3 instead of 1 and 4, because these were false. It'll make more sense in practice, I think. All right, the AND operator, specifically A and B, is going to return an array of the same dimension again as A and B. And this is going to have ones where both A and B were non-zero elements, and zeros when A and B is 0. The OR operator, we use, I don't know what it's actually called, but that vertical slash, I don't know, a break? I don't know. So A break B, I forget what it's called, I don't know. That's going to return an array of the same dimension as A and B again. And this new array is going to have ones where at least one of the elements in A and B is non-zero, and zeros when A and B are both 0. So I think really in practice, I personally think it's easier to understand these when we do like kind of real world examples. So for this, I actually have a script for this. I might go over this next class with you guys. It could be like, let's say, was it a single or was it a home run? If either of those were met, we could get that output. If none of those were met, then we wouldn't get an output. So you could kind of think of it that way. But I might have an example where I go over this in more, I guess, visual depth. It makes more sense, in my opinion, when we use these on more like real world examples rather than just numbers. All right, so here we're using numbers though, so far. So we have two matrices, A and B, and we're going to use the AND operator to find when both matrices, again, have non-zero values. Right, and then if one or both of them have a value of 0, that's going to give us a logical 0. So here we have matrix A, that's 2, 0, 3, 4, matrix B, 5, 0, 0, 2. And so remember a 1, we're going to get a logical result of a 1 if both A and B for some respective index are non-zero. So for our first index in A, that's 2, first one in B, that's a 5. Both of those are non-zero, so we're going to get a logical result of 1. Second index is 0 and 0, so they're both 0, so our result is going to be a 0, a logical 0. Third index, A is non-zero, that's a 3, but B is 0. So because one of them was 0, our result is going to be a logical 0. Basically because not both A and B were non-zero. And the last one, we have 4 and 2. They are both non-zero, so we're going to get a logical result of 1. All right, the not operator. Oh yeah, I didn't talk about short circuit and short circuit or. I don't actually plan on going over these. Maybe I will, but I don't think I've ever used them for stuff that we typically will need to use logical operators for. Alright, but maybe we'll go over that sometime. Alright, so the not operator. Logical 1 when A is 0 and a logical 0 when A is non-zero. So it's doing the opposite basically of what we just did. So here I have a matrix D. Kind of wish I formatted it a bit different. So this is our first row, second row, and third row. And we're going to create a new matrix E for not D. So if we have a non-zero number, that's going to now give us a 0. Before, if we, before if both of them were non-zero, we had a 1. In this case, I can actually just use like one matrix here. So I could say E is equal to not D. And basically, if I have a non-zero number, think of it this way. If it's non-zero, our answer is going to be 0. So looking at our first row, we had 3, 2, and 10. All of those are non-zero, right here, duh. So all of them are non-zero, so our answer is going to be all zeros on that first row. Second row, we have 2 zeros, so now our answer is going to be a 1 for those. Non-zero, our answer is going to be 0. 2 non-zero values here, they're going to be 0. A value of 0 at the end, that's a value of 1. Again, I think it's probably, it seems like really confusing now to keep track of this stuff. Another reason why I think a real world example, I think you can understand it a bit better that way. Okay, the OR operator. So we're going to get a logical 1 when at least one of them is non-zero. Otherwise, if they're both 0, we're going to get a 0. So remember, for the AND operator, both of them had to be non-zero to get a logical value of 1. So, we needed 2 and 5, those were both non-zero, and we got an answer of 1. But for this third value, only A was non-zero, B was not, so the result was a logical 0. But with the OR operator, only one of them has to be non-zero. Jeez. Do a drinking game for how many times I say non-zero. So, again, only one of them has to be non-zero. Okay, so we have our matrix here, A and B, and we're going to create a new matrix for C is equal to A or B. Okay, so first value, 2 is non-zero, B is not, but that's okay because at least one of them was non-zero. So this, I'm going to kind of go like this. So this entire first row, we're going to have 1s because all of these are non-zero. Our second row, at least the first and third are going to be non-zero. But look, B, that value is non-zero, so they're all 1s. Last one, in row A, and in the final row here for A, they're all 0s. So now we need to kind of hope that B has some non-zero values in that last row. We see there are, that's 2 and 3, so those are going to be 1s. The last value for each matrix here was 0, so because both of them were 0, the logical result is 0. Okay. Alright, and then here's the precedence for all of the operators that we just covered in the whole class so far. So parentheses first, arithmetic operators and logical not, so those are going to be evaluated at the same precedence from left to right. Then relational operators, left to right, logical and logical or. Alright, wow, so I guess good timing in the end. We probably have like 20 seconds left. Alright, so that's it for today. I'll upload this video as soon as it's processed to at least 1080p. Oh, it might be later, actually. I have to do something after this, so it'll be up sometime today, though, for sure. Alright, so I'll see you guys on Wednesday, and there might be a little more in this stuff, but we should start going over conditional statements on Wednesday. Don't forget, homework due tonight, even though we went over a lot of it today in class, it's still due tonight by 11:59, and do the supplemental exercises too. That's going to help out. All right, see you on Wednesday.
Thank you, Professor.
Hey, Patrick, would you mind helping me with something real quick?